Hello all, today in this video I'm going to provide a demo in Python to just visualize the activation function. So if you are using the activation function as it is means not an issue, but sometimes if you want to create an custom activation function means in that case you have to define an activation function. In this video that we are just making with the original equation for the activation functions only, but in the same by using the same code, if you are interested in making some custom functions or custom equations for a separate activation function means, and you have to also make them to plot in a graph means you can use this code. So the initially for that we have to import the libraries. Mostly for this we need only one or three libraries. Mostly they are import matlab dot plot and then numpy. Initially we are just importing or defining the Relu activation function. Relu activation function, you may know that it is just an simple activation function. So we are just its maximum of 0 comma x. So in the if condition we are giving 0, and if it is greater than 0 means we have making it to return 0, and if not, if else means it will just return x, and that we are going to plot in a graph, and you can just see the plot for Relu. So this is the plot we will get obtained for Relu. So then we are just making to display an sigmoid activation function. For the sigmoid activation function, we have an equation. So that equation we are going to return, and then that equation we are also going to plot. For that we are using plot dot plot, and we are arranging it within this minus 10 to 10 width, and this sigmoid x, this sigmoid definition only we are calling over here, and again we are arranging it into minus 10 to 10. Likewise only we have did over here this Relu x only we will called over here, and that is only going to display in this graph. Also in sigmoid is also the same criteria. You can note a difference. It is in Relu it is just calling from 0, and from 0 0.0 you can see it is increasing, but in this sigmoid it is also increasing, but here it is an like slope, but here it is like a wedge. So this is the difference between Relu and sigmoid. And also in this we are also going to display the linear equation. For linear equation is just we are going to return it since it's a simple equation only, and then we are going to make it to call in and here graph. So in the graph we are going to define or call this a definition here over here, and then we are making to plot it, and also the title we have given as linear. So this is the curve for this linear. So you can note the difference between the curvatures and curve for the uh, different activation functions like linear, Relu, and sigmoid, etc. Again, we are going to display this graph for tan h activation function. Tan h activation function, it is having an equation that we are going to call in the return function, and that equation and that definition we are calling in the plot, and this is the equation or this is the graph for tan h. So you can make an you can just notice the difference between the different activation functions like tan h, that is its activation functions line plot in for tan h, then linear, then sigmoid, and also like this Relu. So likewise, what are the activation function you want, you can just make it in an definition, you can just plot. And also in some cases if you not ready to use the default activation function as it is, and if you want to make any changes in it means in the equation you can just make any changes, and you can check what is the graph or what is the uh, uh, slope you are getting. So based on that, because every in Mostly here sigmoid you can consider, sigmoid and tan h you can consider as best because it is not showing it is considering every values from -1 to 1, that is tan h, and also this sigmoid it is considering from positive values only, but tan h it is considering negative values only, negative values also. So this is by based on this curve differentiation you can make some changes in the equations, and also you can utilize them as some customs activation layers in your code. So this is the code for custom to make a definition by using the activation function. So in the next video we will make some other demo. So if you are interested in us in making some other demo videos, means please make them in a comment. So if we are aware of it, means we will definitely make a video regarding it. Thank you.